So you can go ahead and answer, right?
Okay. The filter. Sorry. The mixture was filtered into a conical flask.
All right, so that's good. That's good. All right, so the method is clear, right? Is that clear for everyone? The method is clear for everyone?
Yes, sir.
Yes, sir.
All right.
Yes,
Next
sir.
part is the observation. So you would watch the video, right? Ensure before you carry out this experiment, you watch the video. You have to watch the video, right? So you watch the video and then you will note the color of the filtrate or the solid, right? You'll know the color of the filtrate, which would be the liquid that is poured through the filter paper. The residue would be the solid that is left inside the filter paper. Is that clear?
Yes, sir.
So the
Yes,
filtrate,
sir.
Yes, sir.
yeah, the filtrate is the liquid that goes through the filter paper, right? That is left in the beaker, and the residue is the mixture or the solid that is left inside of the filter paper. So you would also answer the question: what happened to the sand and the salt during filtration, right? What happens to the sand and the salt during filtration, right? If the salt dissolves inside the water and the sand is left, right? You would state that, and then you would state what happened during the evaporation of the mixture, right? Then for your discussion, you would answer these questions. What is filtration? Why is the mixture stirred in step 2? You would answer these questions. All right? Is that clear for everyone now?
Yes, sir.
Yes, sir.
All right, so this is due next week. Next week when?
Thursday.
Okay, next week Thursday. All right. So we'll go to the lesson now. Remember that your test also is next week, right? Next week is your last week of the month. Remember, every end of the month we have a test. All right. It's just I believe 30 questions maximum. 30 questions maximum. All right. Let me go ahead and bring this up. So this will be on your test for today. So you need to pay attention. This is coming on your test next week. So you have to pay attention to this. All right, so we're going to do the engineering and design process. So remember, what process does scientists use, right? What method does scientists use to get information? Anybody remember?
Sir, the scientific method.
Right, so the scientific method, scientists use a scientific method, right? So we do not only have one method, we have the engineering design process method, right? Or the engineering design process. So we have the scientific method and we also have the engineering design process. So for today, we're going to explain the stages in the engineering design process. We're going to apply the engineering design process to solve everyday problems and write a report of an engineering design project. All right, that is our objectives for today. So as we said, the scientific method is not the only way to solving problems. Another approach to problem solving is called the engineering design process. So this consists of a series of steps, right? Series of steps engineers mainly use to guide them as they solve problems. All right, so it is cyclical, cyclical, right? Right, is that yeah, cyclical, right? I can begin at any step. Sorry about it. You can begin at any step or move back and forth between steps. So that's what this word means, right? You're able to go back and forth between steps. So an engineer is a person that is trained and skilled in the design, construction, and use of a system or machine, right? An engineer needs to be well versed in language arts as well as math and science. So they mainly deal with the applications, right, and of theories in science. All right, and they are well trained when managing large machines, when building large buildings and constructing bridges and so forth, right? This is what an engineer does. So they have different types of engineer, including the mechanical engineer, electrical, chemical, nuclear, civil, and computer engineer. All right. Are we familiar with any of these types of engineers?
Sir, I know the mechanical one.
All
Me
right.
too, sir. I'm a mechanical engineer. So my father used to be a mechanical engineer, sir.
Okay, that's good. Right. So we have the engineering design process. So the first step, what is the first step here?
Define.
Define the problem.
Right, so we determine the problem, right? We see a problem and we acknowledge it, right, as a problem. What's the next step?
Research the problem.
All right, so therefore we go out and we try and find what?
Find information.
Exactly. So we try and find information on this problem and how we can solve problem and why is it a problem? Why is that situation a problem? The step 3 would be what now?
To brainstorm.
Right. So from the information that we received in the research, right? We try to brainstorm what? What do we try and brainstorm?
Sir, can you repeat the question?
Yeah, so from the research, we know about the problem, right? We know the issues involving with the problem. So now we try and brainstorm what exactly.
The solution, sir.
Right, so we try and come up with solutions to solve the problem, right? Step 4 is what is step 4 now?
Choose the best
Solution.
Right, so from the various solutions that we came up with from step 3, step 4 now, we choose which one is the best and which one can actually work to solve our problem. All right.
Excuse me, sir.
Question?
What did I miss? Randa.
All right, so we spoke about the engineering process and the fact that it is not, the scientific method is not the only way to solve problems or to come up with solutions, right? The engineering process is a series of steps that engineers use to guide them as they solve problems, all right? An engineer is a person that is well skilled and trained in designing, construction, and the use of systems or machines. So these are some types of engineers. All right. Okay, now
Yes,
step
sir.
6. Step 6 is what now?
Third, step 5.
Third, step 5.
Yeah, so sorry about that. Yeah, step 5. Sorry about that. Step 5 is what now?
Build a model or prototype.
Right, so we build a prototype or some form of model for our solution. Just to see, remember we're in the building process, right? We are coming up with solutions and we are now going to step 6, which is what? What is step 6?
Test your solution.
Test your solution.
Exactly. So now we're going to test our solutions to test if our prototype actually works, right? If it's able to actually solve the what?
Problem.
Right. So
Solve
we're going
the
to,
problem.
exactly. So we're going to test now if our prototype is able to solve the problem. All right. Step 6 is what now? Step 7. Sorry.
Communicate your solution.
Right. So we came up with a solution. We brainstorm it. We chose the best one. We built a prototype and we tested it. Now we can finally tell others about the results of our testing, whether it was successful or unsuccessful. All right. And the last step is what? What's the last step? What is our last step?
Redesign.
As needed.
Right. So we go back to the testing process and we see if there's anything that we could change. Right. We go back to the results of our testing process and communicating with others, getting more advice from other persons, from other engineers. We get advice from them as to whether our solution is viable, right? We redesign it based on advice from others, based on our information and also our information from our tests. And it is a cycle because we do this over and over again. As engineers, right, we try and solve new problems every day. So it's always a cycle. There's always something to solve and there's always something to develop on, right? Are we clear?
Yes, sir.
Yes, sir.
Yes, sir.
All right. So this is just a write-up or defining each stage. So as I said, for number one, we identify and describe the issue and what we aim to achieve. So when you look at the questions, what do you want to accomplish? What are the requirements? Are there any limitations? Or who is the customer? Who needs to solve this problem? Who is the person that is most affected by this problem? Then we carry out research. We investigate existing technologies related to the problem. We talk to individuals who share this problem and persons that could possibly benefit from the solution. The third one is that we plan and we involve working, this involves working out specific requirements, what equipments and materials we're going to need and how, where, what's the cost of them, all right? Where can we get them? How can we get them? Then we start to generate solutions. We start to brainstorm solutions. We look at the different ways to solve the problems and of course, select the best way, which would be the next step. It also involves considering the environment, right? The most important, we have to protect our environment as we spoke about yesterday. We have to look on the financial issues, the constraints, right? Limitations, the time, and the culture that we're currently living in. And we select the most feasible idea and assign tasks to the team. All right. So the next step would be to build a prototype. All right. So this is the operating version of the solution, right? We have the solution in our heads, but now we're going to come up with a way. We're going to put this in real time. We're going to make it, our ideas come to life, right? So it is often made with different materials, cheaper to work with than the final version, right? So we put together some materials. This is not the final thing, and we don't invest a lot of money to come up with the final materials, but we're still putting our ideas to real life, right? But it is much cheaper, and we're testing if this can actually work with things that we can find around our homes, in the office, or wherever. So they allow you to test your solution and supply feedback to see if your solution is actually working. So in the picture here, somebody is trying to develop, I believe, a catapult, all right, to see how it works. We see the elastic band here, and we're testing different designs of catapults to see which one is the best one, all right? Number 6 says we're going to test and redesign. We're going to test and redesign. So we're going to try out the prototype. We're going to look if it actually works, and we're going to need to modify it and redesign it before it works the way that we want it to. We're going to look on it. We're going to test it, right? We're going to ask others for help, and we're going to redesign it. We're going to make different changes, what needs to be improved, what needs to be omitted. And finally, we're going to communicate our results. So we're going to provide accurate details of the work we carried out. And this is a very important part in science because we can share our work so it can develop the entire scientific community. All right, so are we clear so far on the steps? Any steps you want me to go over?
No,
No,
sir.
sir.
No, sir.
All right. Anyone not clear? Please let me know. All right, I'll take that as everyone is clear. Okay, let's move on then. So we will now look at a way, right? We're going to look at a way, we're going to apply our engineering design process now. We're going to do this together, right? And you're going to help me to design a engineering, we're going to have an engineering design, and we have our problem here. So although charcoal is made of wood, which is, it's a renewable source of energy, but it manufactured, the manufacturing process damages the environment and creates pollution with the emission of carbon dioxide, right? I see a message in the chat. Yes, the class is currently being recorded, right? And it will be posted as usual. So every year as a society, we produce millions of tons of waste, paper and cardboard, right? Much of this can be recycled. So we're going to use the engineering process to design a process. We're going to use the engineering design process to create a fuel made from recycled materials to replace charcoal, because charcoal damages the environment and we have a lot of waste paper and cardboard. So the first step is defining the problem, right?
Yes, sir.
Yes,
Right, so
sir.
what is the problem here?
Sir, the problem is that they are using too much charcoal and they are damaging the environment.
Right, so that is our problem,
To the trees.
right? And what is the research? What can we research about this now?
We can research how charcoal is made.
Yeah, we can look on how charcoal is made and we can get more information.
Recycling.
Go again?
Recycling. Sir, we can see how we can use it over back again, sir.
All right, charcoal. How we can use charcoal back over again? All right, so
No, sir.
we define the problem, right? Now we're at the research process. All right, so let's go back a few steps. So we're going to look on technologies, right, that already exist. Technologies that already exist, and talk to individuals who share this problem and could benefit from the solution. So technologies that could also exist, we can look on ways that people burn, right? Burn waste paper and cardboard that is beneficial to the environment. That could be a form of research. Agreed?
Yes, sir.
Yeah, as
Yes,
biofuel, right? We could look on biofuel. We could look on how people burn waste paper without releasing toxic things in the environment. So far, we could look if there's anything else. And the next step would be to generate solutions. All right, so we look on solutions of this problem, right? We try and come up with ways and means to recycle, to use these recycled materials to get fuel to replace charcoal. So as you said,
Yes, sir.
the problem, you must manufacture an alternative method for charcoal, for coal stoves from waste paper. All right, so that is what we want to try and do. All right, so we want to use waste paper and cardboard to produce fuel. Right, that's what we aim to do. The research now is to look at different brands of charcoal for sale. So we could measure the size of the chunks. This will help us to decide the size of our briquettes, and we could look at devices we can buy to compress wet paper into cubes or logs. No, we can use think about it. We can use waste paper, right, and turn it into blocks such as charcoal. Like charcoal comes in some little small blocks or small cubes, right? Very small
Yes,
cubes.
sir.
We can find a way now to put waste paper in and cardboard into these size. Agreed?
Yes, sir.
Yes, sir.
All right. So the requirements, right? You can look at the requirements. So that would be identify sources of wet paper or cardboard that can be used to make briquettes. So can we make, borrow, or buy a device to compress wet paper? We try and brainstorm solutions in this particular step, right? We try to come up with ways that we can get a machine, right? Get a machine to see if we can compress wet paper into small briquettes like charcoal. Now the solution, we're trying to brainstorm solutions, and we're coming up with the best one, right? And the most feasible one. So we're going to think of some different ways of wetting and compressing our briquettes. So, and after we wet them, then we compress them, we will try and brainstorm more ways that we can dry them to be able to be transported. All right? So, are you hearing me? Hello? Hello?
Yes, sir.
You hearing me?